Preventative, some beer. Right, preventative maintenance for electric motors. Okay, so we're going to look at something I wrote on blog ages ago. Right, so preventative maintenance. Right, first of all, electric motors. This picture here, you can see it's actually a three-phase induction motor, and this thing here is called a stator. It's three sets of coils wound together. It's one coil for each phase. A three-phase supply you have. If you imagine sine waves, the electricity alternating current goes up and down 50 times a second if it's plugged into a UK supply. So it's going, just picture a sine wave if you can, so go like that, up and down, doing that 50 times a second. With three phase, you've got three of them. Okay, and sort of larger sort of motors, you use it a lot in industries, but just looking at this, you can see you've got that thing is three sets of coils. That's called the stator. This is obviously the outer casing, and the bit that goes in the middle will be the rotor. So that's the bit that spins. I haven't got it on this picture. Right, let's have a look then. So, preventative maintenance. Preventative maintenance programs are the key to reliable, long life operation of electric motors. While induction motors are particularly reliable in service, almost all electrical equipment requires periodic planned inspection and maintenance. Planned preventative maintenance ensures electrical motors and starters are kept in good working condition at all times. This is also critical for businesses that rely on electric motors. A scheduled routine of motor inspection should be carried out throughout the motor's life. The periodic motor inspection helps prevent serious damage to motors by locating potential problems early. Periodic preventative maintenance inspections. Planned electric motor maintenance programs are designed to help prevent breakdowns. Rather than having to repair motors after a breakdown, in industrial operations, unscheduled stoppage of production or long repair shutdowns are expensive, and in marine shipping environments, a potential safety issue. Periodic inspections of motors are therefore necessary to ensure best operational reliability. Preventative maintenance programs require detailed checks in order to be effective. All motors on site, for example, factory, ship, etc., should be given their own individual identification ID number and have a record log. The record log is usually computerised these days. The motor records kept should identify the motor's brand, inspection date, and descriptions of any repairs previously carried out. By record keeping, the cause of any previous breakdowns can help indicate the cause of any future problems that might occur. All preventative maintenance programs should refer to the manufacturer's technical documentation prior to performing equipment checks. There are simple routine maintenance checks that can be applied to all three induction motors, which help ensure a long service life to a motor. Simple checks that can be carried out include a review of the service history, noise and vibration inspections. Previous noise issues could, for example, be due to motor single phasing. The previous vibration that may have been due to worn bearings, which allowed a stator to due to worn bearings being what allows a stator to turn. Other checks include visual inspections for damage and burning, windings tests such as insulation resistance and continuity, brush and commutator maintenance for DC motors, obviously not AC induction motors because they don't have commutators, and bearings and lubrication. Talking about lubrication, on one of my previous videos I did show a motor that the bearings need to be lubricated. Most modern ones, they don't, they're just sealed for life, but you may come across one that does, because induction motors last a long time. pretty reliable. Inspection frequency and the degree of inspection detail may vary depending on such factors as the critical nature of the motor, its function, and the motor's operating environment. An inspection schedule, therefore, must be flexible and adapted to the needs of each industrial or marine environment. Next section, induction motor preventative maintenance. The main failure points of AC induction motors are either the stator coil or the bearings. The bearings are what allow the rotor to rotate. The rotor is the bit in the middle that rotates, and that turns a shaft that's attached to it, and that will power whatever you want your induction motor to turn. Okay, where we got to? Stator. Stator coils are wound coils of copper wire that surround the rotor of an induction motor. In single-phase induction motors, there is a single length of copper wire that is wound as a stator. Tell you what, I'm just going to turn the light on. It's getting very dark in here. Right, let's switch back on. Right, hopefully that's put the microphone back in. Hopefully that's better. I haven't actually got a picture of myself on the screen, so I've absolutely no idea what I look like on camera at the moment. Yeah, like I've been dragged through a hedge backwards probably, but let's get on with this. Right, stator. Stator coils are wound coils of copper wire that surround the rotor of an induction motor. In single-phase induction motors, there is a single length of copper wire that is wound as the stator. In three-phase induction motors, there are three separate lengths of copper wire that are wound together to form the stator. Therefore, in a single-phase induction motor, the stator can go faulty if breakage occurs somewhere along the length of the single wound copper wire. I've written single wood copper wire, that makes sense. Single wound copper wire. In a three-phase induction motor, however, there are other reasons that a motor may fail, and also preventative maintenance checks we can make. The three separate coils of wire contained within the stator of a three-phase induction motor need a high insulation resistance between them. Dust or moisture can reduce the insulation resistance between the three separate coils of wire. If the insulation drops too much, below 1 to 2 megaohms, then the motor may stop working. Periodic checking of the insulation resistance can help identify issues before they prevent the motor from running. Bearings. The bearings, by the fact that they are a moving part and therefore subject to friction, are more likely to fail. Periodic preventative maintenance or can't tell me I'm writing it. Periodic preventative maintenance, visual inspection, vibration testing might help. Well, basically, periodic testing will help identify early indicators of bearing wear. It's all part of the preventative maintenance, ensuring that you've got reliability. Nothing's going to last forever if it's moving. As I said, the insulation resistance can change, moisture, dust, things like that. If that gets into the coils, it can reduce it, and if it reduces too much, it won't work. Okay, I hope you found that interesting. Right, I'm now going to watch my video back and think, why didn't you actually get dressed properly? It's a Sunday. And I'm not really dressed for making a video, so I wasn't planning to make one, but I have. And I hope you found it useful. It's Craig. I'll see you again. Okay, bye.